Alright, welcome to the second part of Complete the Square. In order to keep my promise that the videos would never be longer than 15 minutes, I shortened up the video a little bit. However, I feel like we didn't spend quite enough time changing a standard form to a vertex form using Complete the Square. So I wanted to talk about that today. Now, one of the reasons why I knew in this particular problem to pull out the 5 was because there was a number in front of my x squared that was not a 1. So I know that that's going to have to happen because I need in the parentheses a 1x minus h squared. So what I did here, of course, is you're going to put your g of x plus blank equals, and then the 5x squared minus 50x plus blank plus 128. Now, because there's a number in front of the x squared, I have to pull that out as a GCF. Now, I'm only going to do it to these terms right here. I'm not going to do it to the positive 128 because that will stay outside of the parentheses. Okay, notice that the 5, if I were to redistribute it, would multiply to these 3 terms only. That's why it doesn't get pulled out from the positive 128. So we leave the g of x here. Alright, now, I need a negative 10 divided by 2 is negative 5, and then square that is 25. Now, normally you would think to add 25 to the other side. However, if I were to multiply this 5 back into the 125, or to the 25, it will become a 125. I'm giving away the answers before I can speak. So we put the 125 here in order to match both sides. So let's go ahead and factor. We're going to leave the left side alone and factor this here. So I have a 5 on the outside, x minus 5 squared plus 128. So we are almost in the appropriate form, except that we need to subtract this 125 from both sides. So the vertex form of this is 5x minus 5 squared, and then when I subtract 125 from 128, that's how I get the positive 3. So the vertex that we're looking at here is a positive 5, positive 3. Alright, so let's do another example. I know this is called a you-try problem, but we'll work it together. There's a 1 out front, so I don't have to worry about factoring anything out. So f of x plus blank equals x squared plus 24x plus blank plus 145. So again, no, the 1 in front of x squared means that I don't have to worry about pulling out a GCF. Okay? So the two numbers, so 24 divided by 2, and then square that is going to give me 144. So add that to both sides. So factoring out this trinomial, I get x plus 12 squared. Because 12 times 12 is 144, 12 plus 12 is 24. So keeping the 145 here and the f of x plus 144 here. Alright, so in order to solve, we got to subtract 144 from both sides. So I get x plus 12 on the inside of the parentheses, 145 minus 144 is plus 1. So the vertex we're looking at here is negative 12, positive 1. Okay, another thing that you could actually do is you could go back and check your work. Remember that we can find the vertex in standard form by negative b over 2a. So a negative 24 over 2 times 1 gives me a negative 12 for the x value of my vertex. And when I plug negative 12 back into the equation, I'm going to get positive 1. So either way, I can look at this and say, hey, I've done this correctly. Alright, let's do another example. There's no number in front of the x squared, so I don't have to worry about pulling out a GCF. Remember that the plus box goes after the x term. So negative 6 divided by 2 squared is going to be 9. So I add 9 to both sides. Then the factored form of this is x minus 3 squared. Leave the minus 2 alone and leave the f of x plus 9 alone. So we're almost in the form we need, but I got to get f of x by itself. So to get f of x plus 9, I got to subtract 9 to both sides. F of x equals x minus 3 squared minus 11. So the vertex here is actually going to be positive 3, negative 11, and that is the vertex. All right, let's keep doing some more examples. The more we see, the more we'll understand. Okay. Oops, I need to put my plus blank here. Equals x squared minus 4x plus blank plus 1. There's no number, the number in front of x squared is 1, so I don't really have to worry about that. Negative 4 divided by 2 is negative 2, and then square that as a positive 4. So this is an x minus 2 squared plus 1, and then I have f of x plus 4 here. So all I did was factor out this perfect square trinomial. So by subtracting 4, because I want to get the f of x by itself, x minus 2 squared minus 3. So the vertex that we're looking at here is positive 2, negative 3. All right, so again, f of x plus blank equals 3x squared minus 6x plus blank minus 15. All right, what's going on here is there's a number other than 1 in front of the x squared, so we got to factor that out. 3x squared minus 2x plus blank minus 15. I'm only worried about this trinomial, okay? So the number that goes here is going to be negative 2 divided by 2 is 1, so we're going to put a 1 there, and then 1 times 3 is 3. Don't forget that because I have a 3 in the parentheses, 3 times 1 is 3. So I got to put the 3 on the left-hand side. So leaving the left side alone, we get 3x minus 1 squared minus 15. We got to get rid of this plus 3 here, so we'll subtract 3 from both sides. So I get 3x minus 1 squared minus 18, which means that my vertex is positive 1, negative 18. All right, so we have one last problem. I'd like you to give it a shot, and then we'll talk about it in just a moment. All right, so what happens here, because there's a negative in front of x squared, I want you to pull that negative out first. So we're going to pull out a negative 2 from the 2x squared and negative 16x. When you make your mistake, a lot of people will forget that when you pull a negative out from the negative 16, you're going to get a positive 8. So by factoring the inside of that parentheses, we get x plus 4 squared. Now, 16 was your number, and we're going to multiply that by negative 2. So you're actually adding a negative 32 on the left-hand side. So what that means is this negative, this subtract 32, needs to be added to both sides. So I get negative 2 x plus 4 squared plus 36. So my vertex should be negative 4, comma 36. All right, so hopefully that helps you using complete the square in regarding to changing from standard form of a quadratic to vertex form of a quadratic. Thanks for watching.